নমস্কার, ফান উইথ লজিক ইন লার্নিং ফোরট্রান পার্ট 7 আপনাদের স্বাগত। On the way to become a chemist programmer. So basically we are chemists, students of chemistry, but learning programming. So we are chemist programmer, and it's a journey starting from being a chemist to a chemist programmer. It's a smooth journey, and the journey begins like with preliminaries on computer, language and programmable problems, and then arithmetic statements, constants, variables and operation and assignment. So these were the preliminaries of ForTran. Journey begins, and then the journey takes momentum when you learn transfer of control, conditional or unconditional, if, logical and arithmetic, go to, and then a little bit of flowcharts and algorithm, and finally do loops, nested and implied do loops. And then it continues. You learn arrays, both one-dimensional and two-dimensional, that is subscripted variables, and then input, output and format. And I think now you are ready to handle complex problems or programs. Now the question is when or how a program becomes complex. First of all, the problem itself, when it itself is complex, then of course the algorithm or the program would be complex. But when in most of the cases, practical cases, what it happens that when the size of the program is too long, then it's a problem. Because if it is too long, then first of all debugging itself is a problematic step. Debugging means finding the errors, isolation of the errors and rectifying all those errors. This is one big problem. And then you need more and more documentation. That means in which parts of the program what are being done, right? So you need some documentation. And then most importantly, it is long and problematic because when you need similar kind of tasks in several parts of the program, same program. So I will make it clear what I mean by similar tasks in several parts. Say for example, at one point of your calculation in your program, the computer needs to read three variables a, b, c and find the largest of a, b, c. So okay, it's very simple. We have learned this logic that big equals to a, and then if big less than b, that means if b is greater than big, then you replace big by b value, and similarly if c is greater than big, then big is now c. So if get the largest of the three. Now suppose at another point of your calculation you need to evaluate the largest of another set of three variables d, e, f. Whether d, e, f you may read it, I mean the computer may read it at this step, or it may be that in this portion you have evaluated d, e, f, and at this point after all you need the largest of the d, e, f. So it's not a big problem, you know, because the logic is the same, so you just write it again. In this case it is start from d and then you compare with e and then compare with b by same argument or logic. And again suppose that you need the computer needs to compare pqr and find the largest. Again pqr, either it reads it at this step or it has evaluated earlier, but again it's not a big problem. You just do the same thing with pqr, same logic. Now the point is that actually we are doing exactly the same task repetitively, right? Only a, b, c are replaced by d, e, f, and that again in turn replaced by pqr, but otherwise the problem or the task is exactly the same, and in each case you are getting back the output big, right? So at this point, how if a dummy where x, y, z suppose as dummy variables. Let me make it clear what I mean by dummy. That means I am again using the same logic, either this or that or this portion, the same thing, only I have used x, y and z. But the difference is that unlike ABC or DEF or PQR, x, y, z, they are not assigned any separate location or memory space. That's why they are dummy. That means you will be doing in the name XYZ, but it are dummy. There's a dummy, so they will do the purpose for ABC at one time, then DEF, and then PQR. So there should be a communication between ABC and XYZ. So XYZ would be using the same space that of ABC. In other case, DEF or PQR. So they don't have their own location space, right? That's why they're dummy. And actually, it's not very something new, because unknowingly we are already using this kind of thing. Suppose in your calculation, you need in a number of times or number of places evaluation of sign of something. That something may vary at one point to the other, but basically you are doing the sign of something. Say at one point you need sign of x, x is known, and then at some other point you need sign y, y is known, and maybe some other point sign z, and the result value is out 1, out 2 and out 3, right? So exactly the same thing, we are as if using the same thing at different times. And here we can say that R is a dummy. Here x, y, z were dummy, so here sign R, if you call a dummy something, maybe you can call it a dummy program, then R is the dummy variable, and R takes the value of x or y or z as and when needed. So as if sign R is a separate program called as and when needed with different input only. That means somewhere x, somewhere y and somewhere z. So is it a separate program? Yes, sign R. In fact, we know it as a library function. Okay, we just don't bother that how the library function executes to evaluate the value of sign. It's the compiler's job. They have provided us this library, so we are using this library function as, actually we call it also function, because it is a subprogram, as I mentioned, and the name of this kind of subprogram is called function. As if y is a function of x, we call it y fx. So it evaluates the value of y, a single value y, at a given value of x, depending on the functional form of f, right? So similarly here, sign is the functional form, x is the value at what you want the value of sign x, and y, that means out 1, right? So library function is nothing but a subprogram called function. Quite reasonably it's called function because it gives you back a single value like y equal to fx, right? Well, a separate independent program, we call it subprogram, and it can be called at as and when needed, with, as you have seen, that only the ABC, the input set changes, or sometimes DEF or PQR, and that goes in the name of XYZ, and it evaluates the value, and it returns back the output by name big, right? So that is what we call the subprogram. Okay, in a more sketchy way. So here the subprogram is, we are writing function big XYZ and big X, the same logic I am using, and then it ends with return. Of course, it's not stop like the main program, and then end. Okay. So something are common with main program, something are not common. I will compare it later on. So this is a subprogram, but unless it is called, it has no meaning. So we have to call it in main program. Suppose there you read ABC, and then we just call it, right, y is a function of x, or out 1 is sin x, that kind of thing. Out 1 is big ABC. So the job big does that, find the largest one ABC and gives it back and stored as out 1. So at other point you evaluate DEF or PQR, and we just call big again with input DEF, and this time with input PQR, and you assign to the variable name out2 and out3 to be stored, and then stop and end. So this is how we can use a subprogram and call it in a main program, right? And you see here we call it called. They are called. Okay, fine. So the syntax goes like this: that subprogram, it has a name, and then within bracket we call it the parameters, like x, y, z. They are called the parameters. And for example, subprogram, I have told you that the name of this particular subprogram is called function, and name is given as big. So I have written here function big, and then xyz, that means the parameters xyz. So that is the subprogram part. Now in the main program, you have to call it. And how do you call? You just call it by name by this fashion. That means you just say y is a function of x or y is sin x, like out equal to big ABC, right? So that means the largest of ABC is assigned to the variable out. And here you see the list of input x, y, z, etc. Here ABC. So they are called arguments, and when it is the subprogram defining statement, they are called parameters. So they are actually the same, synonymous almost, arguments and parameters. But one thing to keep it in mind, that there is a correspondence between a connection between these arguments and parameters. Why and how? It should be 1 to 1. What does it mean? It means that A, B, C and X, Y, Z. So you have in mind that I want to replace X by A, Y by B and Z by C. So if it is so, then you have to put the values here A, B, C in that order. If you change the order, then there will be a problem, right? So that is what we mean by 1 to 1. Not only that, so it's order. That means in what order you want to execute or use this X, Y, Z. So following that order, you have to put it here also. And not only that, the data type. Suppose X, Y, Z, if I use X to be real, Y to be integer and Z to be say complex, then in the calling statement again you have to maintain the same order and same data type declaration, right? A, B and C. So that is very important, otherwise it would show you some errors. Now is it the only subprogram, function subprogram? Is there any other type of subprogram? The answer is yes. There is another type which is called subroutine subprogram. So this is called subroutine subprogram. So let us quickly see that how we define, that means the subprogram defining statement, what is it looks like, and then how do we call it in the main program, and then what about the argument or parameters as you say, and then what is the communication way between the main and the sub through input and output. So the syntax goes like that. Again, like the function subprogram, here subroutine, then name, then parameters. Well, example, subroutine A max xyz big. So the same example, xyz, to find the largest of xyz, but that time it was big, but big was the name of the function subroutine, but here big is in the parameter. Of course it is treated as an output in this case, but a new name is given which is not big like the earlier one. It is given A max. You can give also hgb, no problem, but it has to have a name, right? And how I will use this name when I will call it in the main. So calling by name, but this time I have to write like this, call. So unlike the first one, earlier one, here I have to explicitly mention that call whom? The function whose name is the subprogram, the name is A max, and this is the set of arguments. So again, like the earlier case, there is the correspondence 1 to 1, and order by order and by data type there must be 1 to 1 correspondence between the set of arguments and set of parameters. So the same example, so I have only changed the one thing, that subroutine in place of function the name has been changed, Emacs, and big has appeared here, and the same logic is done. And in the main program again we have read ABC and then we have called. So it is called ABC then out one. So in the earlier case it was out one equals to big ABC, but this time out one is part of the argument list, right? And similarly when you evaluate, you want to evaluate the largest of DEF or PQR, then you just again call Emacs, the same subroutine, again DEF the input this time, and this time PQR, but the output is out 2 and out 3 because it replaces big, and big is the output in this calculation subroutine, right? So that is how we use the subroutine subprogram. Well, a few highlighted points common to both function and subroutine subprogram. The number one, subprogram name, it contains different types of variables, the argument list. It can be variable, it can be constant, it can be arithmetic expression, and say for example t is a variable, 6.0 is a constant, and square root of a is the arithmetic expression. So all are equally allowed, and of course you might keep it in mind that they are in perfect order. That means the way you are designing your problem, which one is after what, variable, then constant, then arithmetic expression, so you have to maintain that one. Well, any subprogram can call any other subprogram, but not itself. So in other words, no cycle of calling subprogram, no cycle. That means A calls B, B calls C, and then C calls A. No, this is not allowed, the last step, because you are writing in the fashion that if A calls B, then A should be written first and then followed by B, and then if B uses C or B calls C subprogram, then C should be after B, and then if you ask C to read A, then A should be after C, but A is already declared, so this last step is not valid. Okay, array as parameter is allowed. So initially I wrote that big X, Y, Z, but can it be that big A, where A is an array, maybe so of dimension A 10? Yes, for your convenience you can use even an array as your part of your argument. Well, dimension variable. So the standard and usual practice that whenever we are using A and X, or A is in calling program, X is in the subprogram, and they have one-to-one correspondence, then usually we declare same dimension for A in the main program and X in the subprogram, right? But it's not a must. Yes, we can use a variable dimension, but in the subprogram only. Suppose dimension x10 and that x one-to-one correspondence with A, and then you have to declare dimension, but it can be n, where n is coming through this parameter, right? So n can be varied. Of course it should not exceed 10, but it can be anything less than 10, 5, 6, 7, 8, 9 or 10, right? It can be, but one cautious tip from me, that you better not to use this variable dimension if it is two-dimensional array. But here it is on one dimension only, so one dimension is okay, but two dimension it's a bit dangerous. That I will discuss in my coming video lecture. And two more important points, that often we call the subprogram as a complete program and a separate program, independent separate program. Why complete? Because as we see in a program, that is the main program, we use different types of type declarations, we use library functions, and we can call subprograms, function or subroutine subprograms in the main. So here also in any subprogram, you need to declare the types, you may use the library functions, and also you may call other subprograms, and moreover in both main and sub, end statement is there. So that's why we call it a complete program. And why independent? Because all variables except the parameters and all statement levels are local in a subprogram. What does it mean, local? Local in the sense that they don't have any different space, memory space, location. So they just use the location of other variables declared in the main program, right? And that's why you can use the same variables in different subprograms, or even same statement level in different subprograms. Suppose in a main, if you write do 10 and in another point do 10, then it would be an error. but if you write do 10 in a subprogram which you have already used in the main or in other subprogram, it is perfectly okay. So because that level 10 in a subprogram is very local only, it doesn't have any identity outside the subprogram, right? Outside the subprogram. So that in that sense it's local, and that's why it is an independent separate program. A quick comparative study between function and subroutine. We have to be clear that when and why we use which one, function or a subroutine subprogram. So the first point is usually computes a single value function, and usually subroutine computes more than one values or does more than one tasks. The second, in the function subprogram, the name of the function must have a value. Because the output is communicated to the main through this name only, for example big. But in this case, subroutine case, no value of name is there. In the calling part, you just call it as a library function, but here you have to mention call name and then the argument list. In function there must be at least one argument, but in subroutine there may be no argument at all, though it's a very rare case, but in principle it can be like this. And in function subprogram, return is a must, but again, though not frequently occurring, but return may not be there in a subroutine. A function subprogram does most of the job that a subroutine can do, and a subroutine can do all of the function jobs, right? So basically they are not rival, they are okay, you can say alternatively you can use any one of them, that is the thing. And the star mark is here, so I will explain quickly that when a function can evaluate or may evaluate more than one value, usually it computes only one value. Suppose this kind of function subprogram, xxx is the name, here a, b, c and sum. So sum is treated as output here in this example, and xxx being the name and it has a value, so we have two output, one is through this xxx, another is through sum. And for example, I have done sum as the sum of the three variables a, b, c, and xxx is the product of these. So when you call this function, you can use both the output. So total is for sum, so you can use it to evaluate the average total by 3, and also you can use this xxx name, which is actually the product, so you write product equal to xxx. So that is an example where it can give more than one value. And for the right hand side, this has sign. I will show you that when a situation may be there that you don't need any argument or any return statement in a subroutine subprogram. So suppose this is a subroutine subprogram. Here you see subroutine, then name new, but no bracket and argument parameter list, right? So the first point, there is no argument or parameter, and then it writes something, return is not there, within quote return is not there, because okay, I am not using any return, rather I have used stop and end. And then if you call, then we just call new, because no argument is there, so no parameter argument is there also. And then in the main program I have put another write statement, oh sorry, return is there, and end. Now how it works? Very simple. Effect, the output with stop, that means here if return is not there, so what it happens, if return is not there, stop is there, then the subroutine itself, after executing whatever it is there, that means write, and then it stops, and it stops for all, once for all, that means the program as a whole will be stopped, right, executed, stopped. And so it will write only return is not there, and it will not follow the line after calling statement, that means it will not write this line, okay, because it has stopped inside from within the subprogram itself. But now suppose if I give a return here, not stop, then what would happen? Then as usual it would return back the thing, that means the write statement, return is not there, so it will write return is not there. But unlike the previous case, it will, after calling statement, it will come back to this line, right, and it will write, oh sorry, return is there. So it writes, oh sorry, return is there. So that is the difference. Well, I have already mentioned that this is not frequently occurring case. It's a rare case, but okay, in principle you should learn also this thing. Here a few review question. I am not reading it out because the PowerPoint file would be provided to you later on. So whatever I have discussed so far, it's a quick review. A, B, C, D, F, G, H. These few problems, and then I'll be going for just one or two example. Example for subroutine first. So I'll be using a subroutine in the form stat a n sum a v var sd to calculate actually the sum, the arithmetic mean in the name ave, the variance in the name var, and standard deviation in the name sd of the elements of a linear array A with n elements. So here it goes like this, subroutine stat. This logic is already explained in earlier videos, so I am not going into the depth of this logical flow, but the point is that how I am using a subroutine and I am calling it here in the main program. So dimension x10, I have used the dimension for x10, and here you see dimension an, right? So n is a variable dimension now, because n is, I am getting it, I mean the subroutine is getting it through this parameter list. Because it is one dimension, so I have safely used this variable dimension, but otherwise you can use here a 10 also instead of n, right? And then the name of this subroutine is stat, so I am calling it here call stat, and then the list of parameters x, n, sum. So you see a, the order is important, a, x, so they are one to one, n and then n, then sum, av, var, and sd. So the order and type order must be kept in mind, and then we just write the results and pause, stop, end. So this is a simple example, and now I will run the program. Okay, quickly I will run the program. So here the program is here, and I am running it, and the standard deviation problem. So let me run it a few seconds. I will give not many values for convenience. I will give only 5 or 6 values, and then I will find the average, sum, variance, and standard deviation, right? So how it gives the values, let us see. It's taking a few seconds, just wait. To start with, it takes a few seconds, then next time it doesn't take that much of time. So it's a subroutine example. Yeah, so give a number of data, so let me give you just 5 values, okay, and then you have to give the data. So let me give you 1, 2, 3, 4, 5. So I put it in integer mode, though it automatically it will be taken as real, and you see the result is, okay, he has taken real value 1, 2, 3, 4, 5. The given data is reproducing back, and then sum is 15, average is 3, 15 by 5, so 3, variance is 2, and standard deviation is square root of variance, that is 1.414. So that is how we can evaluate that. And you can use this program for your own data set. You can check it later on. Okay. So next I will go for another example, and the example is of function this time. So computing binomial coefficients a plus b whole to the power n for a given n, say a plus b whole square, n is 2, or a plus b whole cube, n is 3. So what we do, this is the mathematics part, that it's an expansion, we call it binomial expansion, and this expansion looks like this, where this coefficient nc0, nc1, ncl, ncn, this is given by this thing. So it requires a evaluation of a few factorials, right? And it can be thought of that it's a one-step computation, because you have to evaluate ncl for all l. So in the main program, I will be doing for L0 to n for a given n. So n has to be taken as an input, and then in the main program, I will do all for 0 to n L value, and then in this evaluation means it requires some factorial. So I will be using ifact, the function subroutine, for factorial evaluation. So it's a kind of thing that the main program is there and it just uses a function subprogram. Okay, I'm not going to the details of this program, rather the extended version of this that I will show here. Example, subroutine. And subroutine arrow function means I will be using a subroutine which in turn will be using a function subprogram, right? And what is the problem? Here again I am evaluating, of course, the binomial coefficients a plus b whole to the power n, but not like the earlier case for a given n. Rather I will be doing for n equal to a number of values 2, 3, 4 up to k, and k is given this time. So for example, k is 4, then I will be doing a plus b square, a plus b cube, and a plus b whole to the power 4, right? All three. So that is the problem. Of course, it's an extended one compared to the earlier one. Again, I will be doing the same NCL calculation, and it's a two-step calculation. How? Because of course you have to evaluate NCL for all L 0 to n, and that I will be doing in a subroutine, right? And for a given n, I will be doing it in the subroutine, and that in turn uses the function subroutine, that ifact, factorial calculation. So in a subroutine I will be calling and the subroutine will be called for evaluation of all L values 0 to n for a given n, but that n would be varied in the main program 2 to k, where k is taken as the input in the main program, so 2 to the power k. So it's like that a main program uses a subroutine, and that subroutine uses a function subprogram. Now I am showing the, well, what will be the result? It looks like, you know, the very famous Pascal triangle, or it's connected to the typical spectroscopic physical chemistry in NMR spectra. The split pattern, the split peak area is coming in the ratio of Pascal triangle. So it looks like this. That means a plus b whole to the power 0 here, that is 1. A plus b whole to the power 1, that means a plus b 1 and 1. And then a plus b whole square is a square plus 2ab plus b square. So a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube, and so on. So this follows a very beautiful pattern. We call it Pascal triangle, as per the name of after the name of famous Pascal. And I have done this, created this Pascal triangle through this problem actually for a given k, and k for n 0 to k, right, 2 to k. Okay, so the problem looks like this. So it's a subprogram called a subprogram. Well, the function subprogram. So I am not explaining the program subprograms as such, but I'm just using how one calls another. So it's the ifact calculation, it's a function, and it is another subprogram, but this is a subroutine subprogram which is named ibino. That means I for integer, bino binomial, bino, bino, right? And in this subprogram it uses the ifact, right? So since this uses the subprogram, that's why this is placed after this subprogram, right? And now this ibino uses ifact, and this ibino to be used in the main here. So in the main I am doing for all 2 to k and calling ibino, that ibino, right? So this is the main part job, and okay, these are the declaration, and then you need to read the k value, etc., and finally the pause, stop, and end. So this is how it works when a function subprogram and subroutine subprogram are used interchangeably. Well, now I will run the program quickly. So this is my program, binomial coefficient for each n for 2 to k, and it main calls subroutine ibino, which calls function ifact. So let us run it. So I will be using say 5 or 6, and we'll see that for 2, 3, 4, 5, 6 how it is giving you all the binomial expansion for n equal to 2, n equal to 3 and so on. So let me give you 6 and expect the beautiful Pascal triangle. Yeah. So this is for n equal to 2, a plus b whole square, a square plus 2a plus b square, a plus b whole cube. The formula is coming back, a plus b whole to the power 4. So that's a beautiful way of remembering. All on a sudden, if you ask you, okay, can you tell me a plus b whole to the power 6, the formula? One can easily say, so this is the formula. Okay. So that's the job, and I'll be going for my next slide, and that's a bit lengthy. So far I was telling, now you will tell me, because the next slide is, thanks for watching. ভালো না লাগলে এবং লাগলে মন্তব্য করুন প্লিজ। থ্যাংক ইউ।